Good afternoon or evening, AP Calculus students. So this is my Unit 3 study guide slash review packet, answer key, basically, or guide. Answer key, guide. All right, so this packet is on derivative methods and rules, although we started that the last packet. So this packet's actually somewhat shorter, I see, mainly focused on the free response, which I will have videos from other people who have explained the free response attached to this video. But I will go through all of the multiple choice questions. We cover mean value theorem, which isn't really a derivative rule, but also chain rule, implicit differentiation, etc. All right, so let's start with mean value theorem. That is the first topic. And what does mean value theorem say again? Well, hopefully you have your notes, but mean value theorem, if I were to put it into words, it basically guarantees a specific rate of change, right? And this is different. If you remember earlier, I think packet 1 or 2, we learned intermediate value theorem. That guarantees a specific y value, right? So different. The mean value theorem guarantees a specific rate of change. Intermediate value theorem guarantees a specific y value. Well, what do I know about mean value theorem? I know there's some requirements. One, the function, yes, basically must be differentiable. Whereas that's different because for intermediate value theorem, the function must be continuous, which is different, right? Differentiable is more than continuous. Differentiable means the derivative from both sides are equal. And it's also continuous, so it adds on. So also means it's continuous. All right, what is the actual mean value theorem? So I'm going to erase this now. The actual mean value theorem is that my average rate of change, or actually I'll write it first, my instantaneous rate of change is equal to my average rate of change. So basically, that means my derivative is equal to my average rate of change formula, which is f of b minus f of a over b minus a. So by calculating my AROC, I can guarantee that a certain IROC, which is a derivative or slope, exists. So I can guarantee, by calculating for my average rate of change, I guarantee that a specific rate of change, which is a derivative or slope, I can guarantee that exists. So let's see how that applies to a problem. Number 1. All right, let f be a function with the first derivative defined by this. All right, it is known that f of 1 is equal to 7 and f of 5 equals 11. What value of x in the open interval from 1 to 5 satisfies the conclusion of the mean value theorem for f on the closed interval 1 to 5? All right, if it's a multiple choice question, my tip is just to use your equation. So just jump to the equation, right? They may mean value theorem. I'm just going to jump to my equation. My equation was what again? It's the derivative is equal to the average rate of change. All right, cool. Well, let's figure that out. First, my derivative. Well, they actually give us my derivative. Literally, they gave it to you. So you don't even have to calculate for it. You literally just type in the derivative on this side. So x squared 2x squared minus 5 is equal to f of b minus f of a over b minus a. So b minus a is going to be 5 minus 1. F of b minus f of a, that's f of 5 minus f of 1. And this is true because they tell us that here, right? I go from a to b, so 1 to 5. All right, let's go to the next slide and continue to solve this. This side, I don't simplify it yet. This side, I can simplify it a bit. 5 minus 1 is 4. F of 5, well, you might be like, what is that? I'm not given f of x, but they actually give us f of 5. F of 5 is 11. So it's 11 minus f of 1. They gave that to us right here. It's 7. All right. Now I can simplify this. So 11 minus 7, that's going to be 4. divided by 4. So that simplifies to 1. All right. They asked me what value of x on the open interval satisfies the conclusion of the mean value theorem. So I'm just going to solve for x. So to solve for x, I'm going to multiply both sides by x squared. So then I'm left with 2x squared minus 5 is equal to x squared. Cool. I'm going to move everything to one side. So I'm going to subtract by x squared on both sides. So it's going to be x squared minus 5 is equal to 0. That means x squared is equal to 5. And that means x is equal to square root of 5. And specifically, it's plus minus square root of 5. But yeah, square root of 5. So which one of these is my answer choice? That means my answer choice is obviously going to be D. Right? And let's think about what this said again. This said that when I set my instantaneous rate of change, my IROC is equal to my AROC at where? At x equals square root of 5. My IROC is equal to my AROC at x equals root 5. Right. Hopefully that makes sense. Cool. We are going to move on to the next problem. The function f is defined by f of x is equal to 4x squared minus 5x plus 1. The application of the mean value theorem to f on the interval from 0 to 2 guarantees the existence of a value c, where from 0 to 2, the derivative is equal to what? Okay, they name mean value theorem, so I'm just going to jump straight into my equation. F prime of c is equal to f of b minus f of a over b minus a. All right, what is my derivative? Well, the function is defined by this. They don't give my derivative, so let's just calculate for our derivative. My derivative is going to be 8x minus 5 divided by b minus a. Well, I go from 0 to 2, so it's 2 minus 0. F of b is f of 2 minus f of 0. So 8x minus 5 is equal to 2. F of 2 is what? Well, I'm going to take my 2 and I plug it into f of x right here. So it's going to be 4 times 2 squared minus 5 times 2 plus 1 minus, when I plug in 0, same deal with this, but I plug in 0. All right, that means 8x minus 5 is equal to, let me simplify this a bit. All right, the top, I'm just going to do this mentally, but you can use a calculator or try to write it out. But that's 4 times 4, so 16 minus 10 plus 1, so that's going to be 7. These two turn into 0 plus 1, so it's just 1. So it turns into 8x minus 5 is equal to 3, which means 8x is equal to 8, which means x is equal to 1. All right, so remember, this is what mean value theorem does. This is saying my mean value theorem guarantees that my IROC is equal to my AROC at x equals 1. And this is guaranteed only if my function is differentiable, which if you notice, this function right here, it is differentiable because there's no discontinuities, there's no place it's undefined, etc., etc. So yeah, that's what this guarantees. My answer choice is A. All right. Next question. Okay, also names a mean value theorem. So if f of x equals sine of x over 2, and there exists a number c in the interval from pi over 2 to 3 pi over 2, that satisfies the conclusion of the mean value theorem, which of the following could be c? Okay, they name mean value theorem. I am going to just plug in, just start with my equation again. Because this is multiple choice, I don't need to write out anything, right? I don't need to logically, I just need to get the answer. All right, so f prime of c. So first I'm going to take the derivative of this. Well, we need to be careful because the derivative is actually going to require a chain rule. All right, so I'm going to actually just leave the chain rule there. I'm going to write that so I remember to use it. But the other side, I'm going to just fill in. So my a and b are right here. So b minus a is 3 pi over 2 minus pi over 2, f of 3 pi over 2 minus f of pi over 2. All right, cool. Let's do my chain rule now. So for the chain rule, there's a chain rule because I have an outside sine of x function and an inside x over 2 function. Remember, my chain rule is what? Well, it is the derivative of the outside. I leave the inside. Okay. Then I multiply by derivative of inside. All right. So let's do that. Derivative of the outside, derivative of my outside function, derivative of sine is cosine. And I leave the inside the same, right? So the inside stays as x over 2. All right. Then I multiply by the derivative of the inside. So I multiply by the derivative of x over 2. Well, that's just going to be 1/2. All right. So that is equal to this. I can simplify the denominator. The denominator just simplifies to pi. F of 3 pi over 2. Well, let's continue simplifying this. F of 3 pi over 2 means I take 3 pi over 2 and I plug it into my function there. So f of 3 pi over 2 is actually going to be sine of 3 pi over 2 divided by 2. Obviously, you can simplify this. I'm just showing every single step, so it might look a little bit messy. Okay, minus sine of, well, I'm plugging in pi over 2 here, right? So it's going to be pi over 2. Then I have to divide by 2 again. All right, so let's simplify this to make it cleaner. Okay, so it's really 1/2 cosine of x over 2 is equal to, I'll still divide by pi. This is sine of 3 pi over 2 divided by 2 again. That's 3 pi over 4 minus sine of pi over 4. All right, and we just have to solve for this. So let's keep on simplifying. Sine of 3 pi over 4. So this is something ideally we would just know, but even if we, well, yeah, we sort of do need to use the unit circle. Remember, on the unit circle here, I'll draw this really quick. 3 pi over 4 is right at this location, right? Right, so it's a 45-degree angle. All right, remember, the equation for sine is equal to y over r. So at this location, the y value, that's the y value, is root 2 over 2. So square root 2 divided by 2. And the r value is always 1. The r value is always 1. All right, so basically sine of 3 pi over 4 is going to be square root of 2 divided by 2. Same thing with sine of pi over 4. Pi over 4 is right here, right? 45 degrees. And you'll notice the y value is going to be the exact same. So it's also going to be square root of 2 divided by 2. All right, that means this simplifies to 0. So really, my next line is going to be 1/2 cosine of x is equal to 0. Right, because root 2 over 2 minus root 2 over 2 is 0. Cool. I'm going to multiply both sides by 2, so I get cosine of x over 2 is equal to 0. Right? So cosine of something is equal to 0. Well, that means x over 2 has a few possibilities, right? Because the question is, when does cosine equal 0? Well, remember, cosine is equal to x over r. So if I were to draw a unit circle, I want to make this equal to 0. Oh, all right. Cosine. Actually, that's confusing to write. But cosine of x over 2 is equal to 0. Well, when does cosine equal 0? Well, cosine equals 0 at 90 degrees because the x value is 0, and 270 degrees. So at 90 degrees or 270, that means cosine is equal to 0 at pi over 2 radians and 3 pi over 2 radians. All right, so that means in this case, the x over 2 here, this internal angle, x over 2 has to be equal to pi over 2 radians, or x over 2 equals 3 pi over 2 radians, right? Hopefully that makes sense. So there's two possibilities. Okay, well, x over 2 is equal to pi over 2. That means x is going to be equal to pi, or x is equal to, in this case, if I were to solve for this one, it's 3 pi. So which one of these is an answer choice, x equals pi or x equals 3 pi? The answer is D, pi. Right? They don't have the 3 pi option, so my answer choice is D. All right, hopefully that makes sense. Let's move on to the next section, which is chain rule, which we've actually already done a bunch of. So hopefully you got it, sort of. All right, so remember my chain rule. When do I apply it? Well, I apply it when I'm taking the derivative of a function within a function, or a function inside of another function. So you can see here, f is the outside function, and g is the inside function. Right? Hopefully you can see that. When I take the derivative of this, there's a rule that I apply. The rule is this. I take the derivative of the outside, so f prime, and I leave the inside the same. So this g of x stays the exact same. Cool. Then I multiply by the derivative of the inside. So I multiply by g prime of x. All right. So I'm going to write that out, actually. All right. This is basically saying the derivative of outside, leave inside. I'm going to say leave inside the same. And then I multiply by the derivative of the inside. Okay, hopefully that makes sense. That's my chain rule. The practice actually for chain rule is recognizing when to use it. So let's see here. So first, each of these problems, I'm going to write it out. X cubed minus cosine x to the 5th. Why chain rule? That's the first question I need to answer. Well, it's because I have an outside function where I'm putting it to the 5th power, and my inside function is x cubed minus cosine of x. Right? You can clearly see something's like on the outside, something's on the inside. It's not just two functions multiplied together, which would be product rule, or two functions divided, which would be quotient rule. There's one on the outside that encompasses the other one on the inside. All right, let's apply my chain rule. So my chain rule is first the derivative of the outside, and I leave the inside the same. So let's do that. Derivative of the outside function. Derivative of this outside function is going to be a power rule. So 5 to the 4th, right? 5 to the 4th, derivative of the outside. What do I do with the inside? Well, I leave the inside the same. So the inside is this x cubed minus cosine of x. I leave that inside. All right. Then I multiply by the derivative of the inside. So that's the derivative of g. So I'm going to multiply by the derivative of the inside. The derivative of the inside, well, is going to be 3x squared. Instead of minus cosine x, it's going to be minus the derivative of cosine x is negative sine x. So minus negative sine x, which is the same as plus sine x. All right, so that is my answer choice. Where does that show up? That shows up clearly with E. All right, hopefully that makes sense. Next question. All right, I'm going to answer sort of the same things here. First, I'm going to write out my function. It is x times g of h of x. Okay. So first, before I get to the chain rule, what do I notice? This big picture is actually two functions multiplied together, right? It's x times g of h of x. So I'm going to first do product rule. I have to do product rule because the big picture is it's two functions multiplied together. All right, so u is equal to x, v is equal to g of h of x. You'll notice that is a function inside of a function. All right, I'll also write here u prime is equal to 1. right? And v prime is equal to, well, I'm taking the derivative of g of h of x. Here's where I do my chain rule. The question is, why chain rule? Well, because my function has an outside g and an inside h function. You can see that here. My outside function is g, and it totally envelops this inside h function. All right. That means my v prime is going to be what? It's the derivative of my outside, so my outside is g prime. The inside I leave the same, so h of x. Then I multiply by the derivative of my inside, so I multiply by h prime of x. All right, excellent. So I did my chain rule. If you notice, I did my chain rule inside of my product rule, which is fine. Whoa. Product, yes. Oh, sorry, I can't write PROD. All right, and that is fine. I can do that. All right, so I have my product rule. I just need to apply my product rule, right? My product rule is VU prime plus UV prime. So let's plug it in now. VU prime, so G of H of X times U prime is just 1. Cool, so I don't need a times by anything. U V prime, U is X times V prime is this whole thing. It's sort of a lot, but there we go. All right, so that is my product rule. Now what do they say? They said find f prime of 3. All right, so I need to plug in 3. F prime of 3 is literally this ugly thing, but I'm going to plug in 3. So h of 3 plus x is 3. So g prime h of 3 times h prime of 3. All right. So let us solve this now. And you might be like, how do I solve this? Well, luckily they gave us a lot of information, right? You can see they gave us a bunch of info here. So let's see if we can use it. F prime of 3 is equal to g of, okay, h of 3. First, let's see if I know what h of 3 is. H of 3 is 4. So it's actually g of 4. Plus 3 times g prime of h of 3. G prime of, well, remember h of 3 again, we said is 4. So I'm going to write 4 times h prime of 3. Do they give us that? Yes, they do. H prime of 3 is -2. So times -2. All right, let's go to the next line and simplify more. First, g of 4. What is g of 4? Well, they said g of 4 is 2. So I'm going to write 2 plus 3 times g prime of 4. Do they give us g prime of 4? G prime of 4 is 3. Good. So 3 times 3 times -2. Cool. We just have to now actually simplify this. So it's actually going to be 2 plus 3 times -2. That's 9 times -2. So -18. 2 plus -18 is -16. So my answer should be B if we did this correctly. Hopefully I did not make any mistakes. All right. Hopefully you can follow along and see my step-by-step work. Okay. Next problem. Okay. Let f of x equals 2e to the 3x and g of x equals 5x cubed. At what value of x do the graphs of f and g have parallel tangents? Well, if they have parallel tangents, that means their slopes are the same. Right? The tangent lines have the same slope. I'll say that. Tangent lines have the same slope because they're parallel by definition of the same slope. Which means the tangent lines have the same derivative. Which means the derivative of f prime of x should equal the derivative of g. Sorry, the derivative of f of x should equal the derivative of g. So f prime of x equals g prime of x. So we just have to find the derivatives of each. Well, let's look at the derivatives for each. So first, f of x. You'll notice it's 2e to the 3x. First thing I will say, there is an outside e function and an inside 3x function. Right. So my outside function is actually, I'll actually write it out to make it clear. My outside is 2e to some power. My inside function is 3x. All right, so let's take the derivative then. And to be clear, I'm doing a chain rule, right? Because there's an outside and an inside function. So the derivative of 2e to some power, well, remember the derivative of e to something is the exact same. Nothing changes. So it's 2e to some power. And I leave the inside the same, right? So the inside stays as 3x. Cool. But then what am I supposed to do? I'm supposed to multiply by the derivative of the inside. So the derivative of 3x is 3. All right, is equal to, next one is g prime of x. Well, that is just a power rule. So it's going to be 15x squared. Cool. So I have my actual equation now. Let's just simplify it. Well, this turns into 6e to the 3x is equal to 15x squared. And you might be like, how the heck do I solve this? I can't factor it or anything because there's this e to the 3x. Well, here, if you look at my answer choices, this is clearly a calculator problem because we'll never be able to solve decimals by hand. So it's a calculator problem. So I'm going to pull up my graphing calculator. And to solve this equation, well, we have a tool for that, and it's called the equation solver. I'm also going to use another tool just to show us this. I can also use this by plotting the two and finding the points of intersection. All right, but let's first use the equation solver. All right. So solving this equation. All right, so you're going to go to math, go all the way down, and you click solver. Right, and then you'll notice my equation solver asks for my equation to be in the form 0 equals something. So I'm actually going to write it as that. So I'm going to write my equation instead of 6e to the 3x is equal to 15x squared. I'm going to write 0 equals, move everything to one side. So I'll do 15x squared. I'm going to move the 6e to the 3x over. So now it's minus 6e to the 3x. Let's plot this. So 0 is equal to 15x squared. Whoops, that's not squared. Squared. I'm going to use parentheses actually. So let me clear that to make sure I have everything right. So 15x squared and parentheses minus, let's start another parentheses for the 6 second e to the 3x. Okay, that closes my 3x parentheses. I need to add another parentheses to close this one right here. All right, cool. Then you can press enter. And we're going to want to choose a guess. So let's look at my answer choices again. All right, looks like all my answer choices are like close to like negative 0.3. So I'm going to guess negative 0.3. Then I'm going to click alpha and then solve. So this green button, then solve. You'll see here, there's a green solve. And I get negative 0.3655. That rounds to negative 0.366. So that's one way I can solve this. Another way I can solve this is if I go to my graphs and I'm going to plot these two equations. So what was it? 6e to the 3x. And I'm also going to plot 15x squared. I'm going to graph these two. Let's see. Cool, I want to find where they intersect. So let me zoom in just so I can get a better look at this at the very least. That looks pretty messy over there. Okay, that's one of my equations. All right, so it clearly intersects at this point, right? You can see it here. I could probably estimate that. But let's not estimate it. Let's actually solve it. So to solve it, you're going to click second trace. You find where they intersect because that's where they are equal, right? So they intersect. My first curve is that one. My second curve, cool, it's identifying the proper second curve. My guess, it looks like it's right in the middle here. So guess, enter. Cool, negative 0.3655. So the same answer, answer choice B. Excellent. Hopefully that makes sense. And we are going to move on. All right. Final topic for today is implicit differentiation. So, implicit differentiation. First, my notes was, when do I use this? Answer. When do I use this? I use it when x and y are all mixed up in the equation, making a derivative difficult to solve. That's when I use it. All right. Well, how do I do this? Well, let's just do a problem so we can see how we do it. All right. So first, I'm going to write my equation. 3x to the fourth minus x squared minus y squared equals 0. I'm going to write this, but put d over dx of both sides. I'm going to derive with respect to d over dx with respect to x. So left side is 3x to the fourth minus x squared minus y squared is equal to d over dx of 0. All right, that's step one. All right. Step two, you should have this in your notes, but step two is I'm going to derive normally. Actually, I'm going to write this out. Derive normally, but if y term multiply by dy over dx. All right, so let's derive normally. It's going to be 12x cubed minus 2x minus 2y. And here, this 2y term, remember I said if it's a y term, sure, I derive normally, but I also have to multiply by dy dx. So I multiply by dy over dx. Cool. These other ones, the x terms, I don't got to worry about. All right, derivative of 0 is just 0. All right, step 3 is move all dy dx terms to one side of the equation. All right, to do that, I'm going to move this 2y dy over dx terms. Those are all multiplied together. I'm going to move it to the other side. All right, step 4 is I'm going to factor out dy dx and solve for it. All right, this means dy over dx is equal to this whole thing divided by 2y. So divided by 2y, 12x cubed minus 2x divided by 2y. All right, cool. At the point 1 comma root 2, so x, y. That means I have to plug in those values. So let's actually plug those in. X is 1, so it's 1 cubed, minus 2 times 1 times 2 times square root 2. All right, so dy over dx is equal to 2 square root 2, 12 minus 2. It's equal to 10 over 2 square root 2 equal to 5 over square root 2. All right, you might be like, okay, I'm pretty simplified. How do I get this to one of the final answers? Because it doesn't match. Well, one thing to note in math, we don't like radicals, or I'll say square roots in the denominator. And you'll notice I have a square root in the denominator right now. So in order to get rid of this square root in the denominator, I'm going to multiply it by 1. And by 1, I mean I'm going to multiply it by square root of 2 over square root of 2, which is the same thing as multiplying it by 1. Right, so I'm allowed to do that. Because multiplying by 1 doesn't change anything. So 5 times root 2 is just going to be 5 square root of 2. Root 2 times root 2, 2 square roots multiplied by each other, I just get the number without the square root. So 5 root 2 over 2, my answer choice is C. All right, hopefully that makes sense. I'm going to now do the next problem. A curve is generated by the equation x squared plus 4y squared is equal to 16. Determine the number of points on this curve whose corresponding tangent lines are horizontal. Okay, so I'm going to do this next problem. I'm going to leave my steps here written out so I can reference them. All right, x squared plus 4y squared is equal to d over dx of 16. That's my step 1, right? I just take d over dx of both sides. Derive normally, but if a y term, multiply by dy over dx. All right, so when I derive normally, I get derivative of x squared is 2x plus derivative of 4y squared is 8y, and I multiply by, remember, it's a y term, so I multiply by dy over dx equals the derivative of the other side, derivative of 16 is just 0. All right, then I move all dy over dx terms to the other side of the equation. Cool, so move all dy over dx terms to the other side of the equation. That means 2x is equal to negative 8y dy over dx. Right. Okay, I'm going to factor out dy over dx and solve for it. So when I solve for dy over dx, it's going to be 2x divided by negative 8y is equal to dy over dx, because I divided both sides by negative 8y. 2 divided by negative 8, it's actually the same thing as negative 4. So it's negative x over 4y, right, is equal to dy over dx. Okay, determine the number of points on this curve whose corresponding tangent lines are horizontal. All right. Well, that's sort of the next step for this problem. So I did my implicit differentiation. Now my tangent line is horizontal, which means my derivative, which is right here, is equal to 0. So let's just solve for the points where my derivative is equal to 0. Well, if negative x over 4y is equal to 0, I can multiply both sides by 4y. So negative x is equal to 0, which means x is simply equal to 0. Cool. So I know x equals 0. How about y, right? So this, I know basically when x equals 0, 0. Right, so when x equals 0, my tangent line is horizontal. The question is, how many times does this happen? Well, to find how many times this happens, I'm going to plug 0 into my equation. So my original equation is going to turn into 0 squared plus 4y squared is equal to 16. That means 4y squared is equal to 16. That means y squared is equal to 4. That means y is equal to square root of 4, but careful, it's plus minus square root of 4. So actually, there's going to be 2 options. So, because that's equal to plus minus 2, right? So I have 2 options. My tangent line is going to be horizontal at 0, comma 2, and 0, comma negative 2. So my answer choice is 2, because there's 2 points. All right, hopefully that makes sense.
Alright, this is number 3 from the 2007 Calc AB exam, and it's actually one of the lowest scoring questions in kind of the history of the AP exam, and it's not really clear why, and you'll see as we go through. Alright, well, we have a table of values, and we're told that f and g are differentiable, and then they define this weird function for us, h of x, which is f of g of x minus 6. And the first question is to show that there's some value of r between 1 and 3 where h of r is negative 5. And this really sounds like an intermediate value theorem question to me. So since it sounds like an intermediate value theorem question, I want to show that the function is continuous, and then I want to show that it's less than that value and then greater than that value. So let's figure out the values at the bounds, because that's usually what you do. That's going to be f of g of 1 minus 6. Which is, now look up g of 1 in the table, and you see it's 2, so that's f of 2, and then minus 6, and then look up f of 2 in the table, and it's 9, so 9 minus 6, which is 3. Now we're going to do the same thing for h of 3. That's going to be f of g of 3 and then minus 6, which is f of, look up g of 3 in the table, and it's 4. So f of 4, then minus 6, and then look up f of 4 in the table, it's negative 1. So negative 1 minus 6 is negative 7. So negative 7 is less than negative 5, and 3 is greater than negative 5. So what I'm going to do here is I'm going to say that h is differentiable, which means that it must be continuous, because differentiability implies continuity. Then I know that h of 3 is less than negative 5, which is less than h of 1. So by the intermediate value theorem, I am guaranteed that h of r equals negative 5 for some value of r between 1 and 3. Alright, so that's intermediate value theorem. The next question is actually just your classic mean value theorem question. We have to explain why the derivative equals some particular value. And I put the table in here again, but it turns out that we already calculated the values that we need. So we're trying to show that h prime of c equals negative 5 for some c in between 1 and 3. So to use the mean value theorem, I need h to be differentiable. So it's differentiable on the closed interval, and therefore continuous on the open interval, and so the mean value theorem applies. So by the mean value theorem, h prime of c equals h of 3 minus h of 1 over 3 minus 1. I already calculated h of 3 and h of 1 in part A, so I'm just going to copy those values. So h of 3 was negative 7, and h of 1 was 3, or 2, and then this works out to negative 5, as you would kind of expect based on the question. And this was guaranteed for some value of c between 1 and 3 by the mean value theorem, and that's all there is to that.
Hi everyone, in this video we're going to be working on the 2015 AP Calculus AB Free Response question number 6. Now this was a final question of the 2015 AP exam, so pretty much when students got this question they were pretty much tired, but also this was the most difficult free response question in my opinion because of part B and C, which required a lot of work. Okay, so let's go ahead and get started. The first thing you're going to notice is the fact that your equation already starts off with a dy over dx. When that happens, understand that that's what we call a differential equation. So when you see this and you see another equation, y cubed minus xy equals 2, you're probably going to have to use those two equations together at some point. This is the stuff you want to think about when you get stuck on a question like this. So let's go ahead and get started. It says, consider the curve given by the equation y cubed minus xy equals 2. It can be shown that dy over dx equals to that equation. It says, write an equation for the line tangent to the curve at the point negative 1, 1. Keyword, line tangent. When I see that, that's my favorite thing because I know that for part A, all I have to do is y minus y1 equals m parentheses x minus x1. Where your y1, your x1 are your coordinates negative 1, 1. The only thing that we're missing is a slope. We're missing m. Well, how do we find m? M is found by the derivative in calculus. Well, what's our derivative? It's given to us. Our derivative is dy over dx equals to y over 3y squared minus x. So we know what you'll notice is there's an x and a y, and those are the two coordinates that I'm going to plug in. So when we plug it in, you're going to get dy over dx is equal to 1 over 3 times 1 squared minus 1. Don't forget that. That's a mistake that a lot of students will probably make. This will be 1 over 1 squared times 3 plus 1, which is going to simplify to 1/4. That is our slope. So we're going to take this 1/4 and we're going to plug it into here. So that my final answer is going to be this. Y minus 1 equals to 1/4 x minus 1. And then simplifying things, you could possibly make it y equals to 1/4 x plus 1 plus 1. And that right there is our tangent line. Okay? That's not my best one, but there we go. So tangent line problem, think of that anytime you hear it. Write this equation out. x1, y1, figure them out. They'll probably be given to you. M, find your derivative. If your derivative is given to you, just plug it in and that's it. Okay, moving on to part B. By the way, part A was worth 2 points, okay? Part B says, find the coordinates of all points on the curve at which the line tangent to the curve at the point is vertical. And you're going to sit there and go, okay, line tangent to the curve is vertical. Find all the coordinates. Well, the one thing you'll notice is the key word is vertical. Tangent line. Tangent line, I think of first derivative. vertical, how do I find vertical tangent lines? So that's pretty much what they're asking us, vertical tangent lines. You find vertical tangent lines by setting your denominator of your derivative equal to 0. Once again, to find vertical tangent lines, set the denominator of your derivative equal to 0. What this means is this: 3y squared minus x equals to 0. So this is one of those questions that if you didn't know how to do that, there's no way you're going to get that right. But if you did, at least you'd be able to set that up. Now the next thing is, once you have this, this is 1 point, because knowing that a vertical tangent line is found by setting the bottom equal to 0, that's a point. Now in case they ask you for a horizontal tangent line, set the numerator of your derivative equal to 0. Okay? So then our next thing is, well, let's go ahead and find this coordinate. I don't know what to do because I have a y square, I have an x. What am I going to do? This is the part where you go, okay, well, let's look at the equation that they gave us in the beginning. Y cubed minus xy equals to 2. How can I somehow use these two equations to figure out a solution? Well, if this is going to be the line tangent, what if I were to solve for a variable in here and plug into here? And some of you are wondering, well, why don't I try doing that for this one as well? Well, the reason why you couldn't do that for the right one is because there's not a variable that I can get by itself that's going to be easy. This is the problem when this is like a type of problem that you dealt with in Algebra 1 or Algebra 2 when you were working with systems of equation. Which equation is easier to solve for that you can substitute into the other one? I would say it's this one. So I'm going to add x, and I'm going to get x is equal to 3y squared. Meaning anytime I see an x, I'm going to plug in 3y squared. Meaning I'm going to take this and plug it into here, which is going to look like this. Y cubed minus parentheses 3y squared times y equals to 2. And then simplifying it, I'm going to get y cubed minus y squared times y, 3y squared equals to 2. Combine like terms, there's a 1 minus 2, that's negative. This is a cube, I'm sorry. Negative 2y cubed equals to 2. Divide by 2, y cubed is equal to negative 1. Last thing, cube root of y cubed and negative 1. You're going to get y is equal to negative 1. That is my y coordinate. And the fact that I found that gives me 1 point. Now the next thing is, well, how am I going to figure out what the x is? Well, don't forget, this is like a systems equation. Take this and plug it into here. So that means that you're going to get x is equal to 3 negative 1 squared, which should give you a value of x is equal to 3. So our coordinate for where our tangent line to the curve is vertical is going to be at 3 comma negative 1. And this is worth 3 points. How difficult is this question? Very. This was one of the most difficult questions on the free response in my opinion. Now, once again, how did I even know how to do this? Well, the first thing for part B, the fact that it said vertical tangent line. Vertical tangent line is found by setting the denominator of your derivative equal to 0, which is what we did right here. Problem is, we were stuck. How am I going to solve for this? Well, let's look at the other equation that was given to me. I wrote it over here. Well, because there's two equations, and this is going to be a vertical tangent line for this equation, let's think about substituting things into one of the equations. Well, I'm going to get one of the equations by itself, which is easier to get this one, so I add x, that's why I have x equals 3y squared, and I plugged it in, and just a little bit of algebra to solve it. Okay? And then I found the coordinate, which ended up giving me the final 3 points of that part of the question. So as of right now, we've received 5 out of the 9 points in part A and part B. So if there's one thing you want to take out of from part B, vertical tangent lines is found by setting the denominator equal to 0, and horizontal tangent lines is found by setting the numerator of your derivative equal to 0. In case you're asked that, which I really think you might be. Part C. Part C says evaluate d squared y over dx squared. That right there is second derivative. Well, the good thing is we already have the first derivative. And my first derivative is a quotient, meaning I'm going to have to apply the quotient rule. Also, they want me to evaluate this at the point x equals negative 1 and y equals 1, meaning that once I find my second derivative, I'm going to plug this in. Now, this is the thing you have to ask yourself. When I find this second derivative, there's a y and an x. This is implicit differentiation, meaning that every time I find a derivative of y, I'm going to have to add a dy over dx. Things you want to ask yourself as you're attempting these problems. So when I find this derivative, I'm going to do this. So I'm going to write out the equation. And this is going to look like a monster when we're working this out. So dy over dx is equal to y over 3y squared. I'm just rewriting the question. Now I'm going to attempt my solution. Now remember, when you find this derivative for part C, it's going to be a quotient rule. How do I know it's a fraction? And this is going to be my answer. Low d high, derivative of the high, is 1. But because it's y, don't forget I have to add 1 dy over dx. So low d high, derivative of the high, minus the high times the derivative of the low. When I figure out the derivative of low, the derivative of 3y squared is 6y, but because it's y, don't forget dy over dx. Derivative of x is minus 1. All over low squared, which is 3y squared minus x squared. So once again, low d high, derivative of high is 1, add dy dx because it's y, minus high, derivative of the low, derivative of 3y squared is 6y, but because it's y, add dy over dx, minus derivative of x, which is 1, over low squared. Now your next step when you get to this point is, a lot of people will try simplifying, but there's no reason to simplify. We already know that this is equal to the second derivative. And what they were asking us to do was evaluate at x equals -1 and 1. So why don't we just go ahead and plug it into all the y's and x's. So now when we plug it into all the y's and x's, this is what you're going to get. You're going to get 3 times 1 squared minus 1. Please do not forget that. That's where a lot of students are going to make mistakes. And then derivative of the y. And you're like, wait, what? First derivative, how am I going to find that? Don't forget, they're going to give you that. They gave you that. So plug in -1, 1, -1, 1 into this equation. Now, in case you forgot, that was the same exact thing that we did in part A. Okay? In part A, when we found the line tangent, we plugged the -1, 1 into this equation. But I'll plug it in again. I'm going to get 1 over 3, 1 squared minus 1, so plus 1. So it gave me a value of 1/4. So anytime I want to find a derivative at -1, 1, I'm going to plug in 1/4. So example right here. Plug in 1/4 minus, once again, keep plugging everything in. 1 times 6 times 1 times 1/4 minus 1. All over, and it looks like a mess like I told you. This is one that you have to be very careful. So once you find your derivative, plug in the values. 3 times 1 squared minus 1 squared. Okay, now when I work everything out, this is what I'm going to get. I'm going to get 1 squared, 1 times 3, 3. This is going to be a positive 1, so 3 plus 1, 4. Times 1/4 minus, and then here 6 times 4, etc. Simplify things, work it out. You're going to get an answer of 1/2. And then followed by all over the bottom squared. 1 squared, 1 times 3, 3. 3 plus 1, 4. 4 squared, 16. And then simplifying a couple more things. Simplifying this is going to end up all simplifying to pretty much 1 minus 1/2 over 16. Now the one thing I'll do is 1 minus 1/2 also is 1/2 over 16. And because it's 1 over 1/2 over 16, I'm going to put this over 16. I'm going to keep change flip. This is going to be 1/2 times 1 over 16, which is going to be 1 over 32. And that is my answer. Okay? Was this complicated? Yes. The fact that you have to do all of the pre-algebra steps just to solve for my 1 over 32. This is my derivative, my second derivative at -1, 1. Now, just to let you guys know, if sometimes they might ask, is this concave up or concave down? Well, because remember, you plug in second derivative, which is concavity, and you plugged in a point at -1, 1, and you got a positive value, that would be a concave up, just in case they ask you that question. So, you got 2 points for being able to determine the implicit differentiation, everything in purple. 1 point for being able to recognize that you would plug 1/4 into every dy over dx. And the last thing is being able to get, the last point was getting 1/32. Okay, so this was a difficult question. Try practicing it, especially understand B when it asks you to find vertical tangent lines saying the bottom equals 0, horizontal tangent lines to the numerator equals 0 of the derivative, and also anytime you find a second derivative, if you have to find derivative of y, make sure you add dy over dx. And what is this dy over dx? In the original equation when they gave it to you in the beginning. Okay? So, thank you guys for watching. I hope it helped, and let me know how it went. Good luck.
What's up? I'm Vin, and today I want to go through the 2018 Calc AB/BC free response question number 4. So let's get started. For part A, we have to do two things. We're going to estimate h prime of 6, and then we're going to interpret the meaning of this in the context of the problem. Now, if we want to approximate h prime of 6, what we're going to do here is we're going to pick two values of t that are really close to 6, something like 5 and 7. So these are going to be the points that we use to approximate the instantaneous rate of change. So we're going to do h of 7 minus h of 5 over 7 minus 5. Now, ultimately, we have to use correct units. So the trick to always getting the units right is thinking about for the function values h, the units are meters. So we're going to write meters here over the values for t, see the 7 and 5, the units are years. So we're going to say meters per year. And now we just have to simplify this. So this is going to work out to 11 minus 6 over 7 minus 5 is 2. And we have meters per year. And this is going to work out to 5 over 2 meters per year. But now for this next part, we have to interpret the meaning in the context of the problem. So the trick to this is I just think about if this was just a function without a story behind it. If I said something like h prime of 6 is greater than 0, that means that h is increasing at t equals 6. So now I just have to piece all of this together. And instead of saying h is increasing, so I'll leave a blank here. Obviously on the AP test, you don't have to underline it like this. But instead of saying like blank is increasing, we just have to fill in the blank and think about which function does h model. H models the height of the tree at any given time t. So what we could say is that the height of the tree, that's what's increasing. So the height of the tree, this is what's increasing. And this is increasing at a rate of approximately, so now we're writing the word approximately here because remember, this is just an estimate. So at a rate of approximately, and now we write our answer, the 5 over 2 meters per year. And we could specify here too at t equals 6 years. For part B, we're going to use the mean value theorem. And the giveaway is that we have to explain why h prime is going to equal 2 at some point between 2 and 10. If it were intermediate value theorem, they would say something like this. Explain why there's a value t such that h of t is equal to, let's say, 8. And notice on our way from 1.5 to 15, we have to pass through 8. But notice we're talking about h prime, so definitely the mean value theorem. Now, the first dilemma we're going to run into in this question, or the first trap, is, well, one thing I see a lot is that students always assume that the endpoints are going to be the ones that we use when we find the average rate of change. So they're just going to do h of 10 minus h of 2 over 10 minus 2. But notice 15 minus 1.5 is 13.5 over, and then we have 10 minus 2 is 8, and this is not equal to 2. Okay, so we're not going to use the endpoints here. So this is a very annoying little trap here. So what we have to do is we have to go on a scavenger hunt for 2 points that have a slope equal to 2, and these are the points here. So what we're actually going to have is h of 5 minus h of 3 over 5 minus 3. And if we complete this, we're going to have 6 minus 2 divided by 2, and 4 divided by 2 is equal to 2. So there's our 2 points that we need. But in order to use the mean value theorem, we have to state that our function is differentiable and continuous. And notice they told us our function is differentiable. So since h is differentiable, so once we make the statement that h is differentiable, differentiability implies continuity. So h is differentiable implies that h is continuous. And now once we state this, once we state that h is differentiable and h is continuous, now we could use the mean value theorem. So we're going to say by the mean value theorem. And now for there exists, we're going to say there exists with the backwards capital E. That's a nice abbreviation of there must be. So there must be a value t. And t is, in this case, going to be between 3 and 5. Notice we use t equals 3 and t equals 5 for our function. So the t value is going to be between 3 and 5. And now we could throw in our conclusion such that h prime of t is equal to 2. Okay? And this is going to wrap it up because, once again, we already showed the work for finding the average rate of change between t equals 3 and t equals 5. So now we could just tack that onto our conclusion here. Now, what might be throwing people off is, notice they said to explain for the interval from 2 to 10, and in our explanation we use the interval from 3 to 5. But one thing to be mindful of is that when you're between 2 and 10, our subinterval, which is not necessarily drawn to scale here, but from 3 to 5, notice that this is a subset of the bigger interval. So if we're trying to find a value t between 2 and 10, and we found one from 3 to 5, the one from 3 to 5 does count as a value t between 2 and 10. Now for part C, we want to find the average height, and we have to know this formula when we show up to the AP test, the average function value formula given here. And we're going to apply it to this function for h between 2 and 10. So we're going to have 1 over 10 minus 2, the integral from 2 to 10, and then we have h of t dt. And this is going to be equal to 1/8, and then we have the integral from 2 to 10, and we have h of t dt. Now, just in case you forget how to do a trapezoid sum, one thing that will be really helpful is drawing this out. So if you have a hard time remembering formulas, then the trick is to just plot the points from the table and now connect them with trapezoids, since they're telling us to do a trapezoid sum. So we just draw in these trapezoids, and then what we're going to do is we're going to find the area of these 4 trapezoids and then just add them together. Okay, but notice the fact that it's average value means there's going to be a 1/8 in front. So this integral is, or this expression is roughly equal to 1/8, and now we'll throw in our bracket. So the area of a single trapezoid is 1/2 height base 1 plus base 2 multiplied together. So what we're going to have first is 1/2 times the height from 2 to 3 is equal to 1, and now we have base 1 plus base 2. So we have 2.5, I'm sorry, we have 1.5 plus 2. So we have 1.5 plus 2, and that's going to give us the area of the first trapezoid. Now the second trapezoid, we have 1/2. The height is equal to 2 because we're going from 3 to 5 now. So we have half times 2, and then we have 2 plus 6. And then we got 1/2 times the next subinterval here from 5 to 7 is going up 2, and then we have 6 plus 11. Now the last one, we have 1/2 times this subinterval from 7 to 10, we're going up 3, or across 3, and then we have the bases are 11 and 15. So we close this, and then we could throw a bracket around the end like this. And now just be mindful, the bases are the parallel sides of a trapezoid. So that's why it does throw people off sometimes, but the bases are actually going vertical here. And now the beauty of this part of the AP test is we don't actually have to simplify. We could just leave our final answer like this and say that this is the average height of the tree. What's up? I'm Vin, and today I want to take a look at the 2021 AP Calculus AB free response question number 5. So let's get started. For part A, we just have to show that the derivative dy dx is y cosine x over 4y minus sine x. So it's pretty nice of them that they told us what we should be aiming for. So we're just going to take the derivative of the original equation here with respect to x. So we have 2y squared minus 6 and then equals y sine x. So going forward with this, on the left side, things are a little bit easier. We're going to do the power rule here. So we're going to have 2 times 2y giving us 4y. But remember, anytime you take the derivative with respect to x of a y term, you have to tack on a dy dx. The derivative of minus 6 is 0, so we're just going to leave that be. And then on the right side, we have to use the product rule. So we're going to have the derivative of y is 1 times dy dx times sine x, plus we have to make sure we use the product rule. We have y times the derivative of sine x is cosine x. So then from here, we have to get all the dy dx terms on one side. So we have 4y dy dx, and we could subtract the dy dx sine x on both sides. So we have minus dy dx sine x, and this is equal to y cosine x. So from here, all we have to do is we're going to group the dy dx terms together. So we could factor out dy dx, and we're left with 4y minus sine x, and this is equal to y cosine x. So the last thing to do here is just divide both sides by 4y minus sine x. And our final answer, we'll just write off to the side here. So these factors cancel out. We're going to have dy dx is equal to, and we have 4 cosine x all over, let's just fix that a bit, 4 cosine x over 4y minus sine x. For part B, we want to write the equation of a tangent line to the curve at this point 0, comma, square root 3. So what we need to do here is we're going to plug in the point to our derivative, because the derivative is going to tell us the slope of our tangent line. So we're plugging in this point here, and just make sure we're plugging in square root 3 for y. So we have square root 3 times cosine of 0 over 4 times the y is square root 3, and we have minus sine of 0. Well, cosine of 0 is 1, so this is just going to give us square root 3 over, and we're going to have 4 square root 3 minus 0, because sine of 0 is 0. So now this simplifies. This is just going to reduce to 1/4. So this represents the slope of our tangent line. So there's a few ways we could write this out. We could call this our x1, y1, and then we have y minus y1 equals the slope 1/4 times x minus x1. So you could leave your answer like this. An alternative way to write this, though, if you want to write it in y equals mx plus b form, just notice here, this is not only a point, it's the y-intercept of our line. So we could also just say y equals 1/4 x plus square root 3. But remember, you don't actually have to solve your equation for y. You could leave your answer like this and get full credit. For part C, we're trying to find the coordinates of the point where the line tangent to the curve is horizontal. Now, this phrase here, the fact that we have a horizontal tangent means the slope of the tangent line is going to be 0. And since our derivative is in the form of a fraction, we're going to set the numerator equal to 0. If we set the denominator equal to 0, that's going to tell us where the slope is vertical. So what we have here is we're going to say horizontal tangent. So a horizontal tangent, so we'll just explain our reasoning here. So a horizontal tangent implies that dy dx is equal to 0. And this implies then that the numerator y cosine of x is equal to 0. But now we have to be mindful. Notice they said since we have 0 is less than or equal to x is less than or equal to pi, and we have y is positive, then this tells us that y cosine x is equal to 0 when cosine of x is equal to 0. And then what's our solution here? This tells us that x is equal to pi over 2. Because notice x has to be between 0 and pi. So technically there are infinite answers to this, but this is the one that we're going with. So then from here, we have to think, all right, we want to find the coordinates of the point. So what we could do is we go back to the original equation. The original equation was 2y squared minus 6 equals y cosine x. We're just going to borrow that. We have 2y squared minus 6 equals y sine x. So since we have to find the coordinates of the point, we need not only the x, but we also need the y value. So we're going to borrow this here, and we have 2y squared minus 6 equals y times sine of pi over 2. And sine of pi over 2 is equal to 1. So that's going to take this to 2y squared minus 6 is equal to y. And then if we rearrange this, we have 2y squared minus y minus 6 is equal to 0. Now, depending on how good you are at factoring here, we're going to use the AC method. You could probably get away with using guess and check here, but I just look at the AC term. I have 2 times negative 6 is negative 12. So that's my AC term here. So this is our AC term. Our B term is negative 1. That's the coefficient in front of the y. So then I need two numbers that have a product of negative 12 and a sum of negative 1. And the two numbers are going to be negative 4 and 3. So then I rewrite the middle as 2y squared. And then instead of minus 1y, I have minus 4y plus 3y minus 6 is equal to 0. So we factor this a little bit more. We're going to factor the first two terms and the last two terms. We got 2y times y minus 2, and then the greatest common factor here is 3. We're left with y minus 2, and notice we have matching factors. So then get y minus 2 times 2y plus 3 is equal to 0, which tells us that we have two roots. We have y equals 2, and we have y equals the root of this factor would be negative 3 over 2. But this one we reject because before we said y is going to be greater than 0. So then we just write out our final answer here. We had an x value of pi over 2. The y value that we're going to go with is y equals 2. So we could say the point is pi over 2, comma 2. So here's our solution to, this is our solution to part C. So for the last part here, we want to determine if f has a relative minimum, maximum, or neither. And we're not going to use the first derivative test here because the derivative dy dx is in terms of y and x. So it's going to be easier to use the second derivative test. So we start by finding the second derivative. And we're going to have to use the quotient rule. And we're going to have the low function here. We have 4y minus sine x times the derivative of the function in the numerator. And we have the derivative of y is dy dx times cosine x. And then we have plus y times the derivative of cosine x is minus sine x. So that's the first part here for our quotient rule. But then we have minus, and what we have here, we have low d high minus high d low. So we're going to take the derivative of the low function. So the derivative of 4y is 4 dy dx. And then minus the derivative of sine is cosine x. And this is all over the denominator squared. So this is a really messy second derivative. So now for this next part here, we're going to evaluate this at the point we found in part C. So d squared y over dx squared at the point pi over 2 comma 2. That was the point we found in part C. Now, one thing to be mindful of, in part C, what we determined was the point where the slope of the tangent line is horizontal. So what that means is that the slope at pi over 2 comma 2 is equal to 0. So sometimes students will lose sight of the fact that they already did the heavy lifting for part of this question. So just know, anytime I plug in the point pi over 2 comma 2 to dy dx, it's just equal to 0. So it simplifies really nice. So now we just go piece by piece. We have 4 times 2 minus sine of pi over 2. And then in the second parenthesis here, we have dy dx. So automatically I have 0. So I'm not even going to bother plugging in here, but cosine of pi over 2 is also 0. And then what we have is we have plus y is equal to 2. So we have 2 times negative sine of pi over 2 is going to give us negative 1. And now we have minus y is equal to 2. We got cosine of pi over 2. And cosine of pi over 2 is 0. So whatever this stuff equals here, doesn't matter that this is 4 times 0 minus 0. This whole last piece here is just going to wipe out. And this is all over. We have 4 times 2 is 8 minus sine of pi over 2 is 1 squared like this. So now we could clean this up a bit and we'll give ourselves more space. So what we're going to have here is the second derivative evaluated at pi over 2 comma 2 is equal to, we have 8 minus 1, which is going to give us 7, times 0 plus negative 2. So we have times negative 2, and this is over 7 squared. So this becomes 7 times negative 2, which is negative 14. Or I could just write it like this. I could say 7 times negative 2 over 7 times 7. So the 7 over 7 cancels. This whole thing simplifies to negative 2 over 7, which is less than 0. So now I think about this very, very carefully. I always forget the results of the second derivative test, but what I do think about at this step is I think, okay, if my second derivative is negative at a point, when your second derivative is negative, that means your curve is concave down. And if I have a critical point and my curve is concave down at the critical point, it makes a relative maximum. So we could say here, since the second derivative is negative at this point, and the first derivative is 0 here, by the second derivative test, pi over 2 comma 2 is a relative maximum. Okay, well, this is going to conclude this video on the 2021 AP Calculus AB Free response question number 5. If this video was helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comment section below. And thanks for watching.